All right, so let's start the session now. Hi, everyone. Welcome to the second session of Attacking and Defending Active Directory, the Beginners Edition Bootcamp. This is the January run of the bootcamp, January 2022. So we discussed enumeration in a lot of detail in session one. At the very end of session one, we started looking at a bit of more intrusive enumeration, that is, where we may, prior to this, the only thing that we had, or the only enumeration that we were doing was requesting information from the domain controller. Now, if we limit our requests to the DC, there are high chances of mixing with the existing traffic in the network. A domain user leaving a 4624 that is log on and 4634 that is log off on a DC are absolutely fine and common. However, at the end of the previous session, we started looking at the ways that that enumeration that is pretty fruitful, usually pretty fruitful, but would be noisy as well. So what we first took a look at was hunting for local admin privileges on other machines in the domain. So the idea is you go to the DC and request a list of computers from the DC, and then you go to each and every machine and check if your current user has local administrator privileges on that machine. So we discussed that this leaves a 4624 and a 4634 on the DC, which is fine. However, it also leaves the same two entries on all the machines in the domain, and in addition to that a 4672 special logon or admin logon where you have any success. So you will not only create a network spike, you will also leave multiple log entries on all the machines in the domain in a quick succession. So that would be that would definitely result in detection. Right. Now, another enumeration technique similar to that, but far more effective if successful, is looking for a session or logon event of domain admin. So the idea is pretty similar to the previous one. When you run this command, find domain user location, without specifying any user group identity, the first one here, when you run this, a request is sent to the domain controller, and two pieces of information are requested. One is a list of computers, second is membership of the domain admins group. Now, armed with this information, the function goes to each and every machine in the domain and tries to list sessions and logged on users on the machines. Now, if it could list a session or currently logged on users, if it could list any one of them or both of them, then it checks the session or the logged on user with the membership of the domain admins group. If it matches, that means that we can list sessions on we have found out a machine where a domain admin credentials could be available. And if we have local admin privileges on that machine, it may be possible for us to extract the credentials. Please keep in mind, to list currently logged on users, you must have local admin privileges on a machine. To list sessions on a machine prior to server 2019, you can list sessions on any machine without having any special privileges. However, if the target is a server 2019 machine, you would not be able to even list the sessions there. Right? But this is pretty useful to quickly escalate your privileges to domain admin. But just like the previous one, you will still leave a 4624 and 4634 on all the machines. So what is the way of using this properly? Run this function on not more than a couple of hundred machines at a time. A question is, what is the difference between a session and logged on user? I would say we use the term logged on user for logon types that result in interactive access. Let's say logon type 3, that is WMI and partial remoting. In fact, let me rephrase that. When you say a user is logged on, a user would always have a session as well on that machine. But we differentiate them here because it is easier to list sessions than to find out the exact logged on user. Right. So, for example, even if a user is accessing, for example, a service on that machine, we would still have a session, that is authentication was done on the DC because it is a domain. We will still find a session there. In case of logged on users, this would, I believe, also list locally logged on users there. Now, once you have find out a machine where a domain admin session is available, let's check if the current user has admin access. For that, you can append check access to it. So this is, of course, pretty noisy. So if you use the stealth parameter, only some of the high value servers like file servers and DFS are tested. That is, your request does not go to all the machines in the domain, but only to some high value ones. And that wraps up actually our enumeration part. Now let's talk about local privilege escalation. Now in any Active Directory environment, there are multiple scenarios that may lead to privilege escalation. So we took a look at how we can hunt for local admin privileges, how we can hunt for high privilege domain accounts. So here, so the last one that we discussed, find domain user location, would not give you directly interesting results when run as a student user. So we'll use that later on. But let's take a look at the previous one, hunting for the local admin privileges. That is this one. We can use either find local admin access, find WMI local admin access, or find PS remoting local admin access. I like this one the most because in my opinion, this is the most reliable and is usually allowed across most firewalls. So let's start InvisiShell. Load find PS remoting local admin access and run it. So this was pretty fast because we are in a very small lab environment. So what happened when we ran this is this script requested a list of computers from the DC and then made a request to each and every machine and tried to run a PowerShell command in parallel on all the machines in the domain. In case of an error or an access denied, we did not show, the script does not show any output. In case of success, we get the output. So what does this mean? This means that our current user, student 1, has administrative access on dcorp admin SR. All right. So that was about hunting for local admin access. So I was saying, when we run this script, and that script tries to find out if your current user has local admin access on any other machine in the domain. So what the find PS remoting local admin access script does, it went to the DC, requested a list of computers, and then it checked on each and every machine in the domain if the current user has domain admin, has local admin access anywhere. So what we got and as an output is dcorp admin SRV here. What does that mean? That means our current users, dcorp student 1, has local admin access on dcorp admin SRV. I prefer this one. The reason is, if you take a look at the source code of this script, I'm using invoke command there. Now, invoke command is a PowerShell commandlet that can run commands parallelly on thousands of machines. And that is why it is super fast. And it is enabled or allowed by default across Windows Firewall on server roles. That is why I prefer this one. All right. So now let's come to privilege escalation. Now, how do you escalate privileges locally on a Windows machine? That is, on, let's say you have a foothold like you have in the lab. How do you escalate privileges locally? There are various ways of doing that. You can abuse missing patches. Please note that when it comes to security patches, vulnerabilities that allow local privilege escalation are fixed at the last. I mean, they have the lowest priority. So if you have access to exploits, or if you can develop exploits for some local privilege escalation vulnerabilities, that could be helpful. Then comes automated deployment. For example, there are files that are left by a lot of automated deployment tools like sysprep.xml, unattend.xml, etc., that may contain credentials in clear text for local administrator, and in some cases, even the domain administrator user. Similarly, auto-logon passwords. What is auto-logon? It is used for, as the name suggests, automatic logon. The password and the username and the password are stored in clear text in registry, and any user can read them. If you've never seen auto-logon in action, you have not probably tested an organization that belongs to industries like hospitals, advertisers, kiosk operators. That is where there is no one to log on to a machine. Someone would simply turn on the power and probably never turn it off, or even if it is turned off, the only thing that someone will do is turn it on back again. So in those cases, auto-logon is used a lot. So you can abuse that as well. Then another registry setting that used to be pretty prevalent, but not as prevalent as it used to be anymore, always install elevated. Now, this registry setting allows any user to run the specified MSI, that is an installer, as system. Then there are misconfigured services. So issues like What is an MSI? Microsoft installer. So installation packages that you can use to install stuff. Then comes the misconfigured services part. Now, there are different types of misconfigurations that Windows services may have. Like unquoted service path, service binary issues, service permission issues, etc. This is the one that we are going to focus in the class. Then also misconfigured services are pretty prevalent, and you will find them usually even in real-world assessments. Then DLL hijacking and similar issues. This is also something that you will find a lot of times in real-world assessments. And finally, any NTLM relaying stuff, also known as won't fix. So Microsoft refuses to fix NTLM relaying attacks. So if you can find any way to relay NTLM hashes, like for example, the Petit-Potam attack or anything like that, then it is also pretty useful for local privilege escalation. So another category of attacks that, not really category, but an example of NTLM relaying is the potato category of attacks. That's pretty interesting, very useful, and is never fixed. So why Microsoft refuses to fix it? They say, and it is, to be honest, true to much extent, that it was Server 2008 when they introduced AES. So probably it's time that organizations kiss goodbye to NTLM authentication. I mean, it's easier said than done, but that's what Microsoft's stand is. Yes, so NTLM uses RC4. So they say, okay, do not use NTLM anymore, use AES. A question was, just want to clarify, do all MSIs run as system? No, the MSIs that are specified in this registry setting, that run as system. Should we expect other priv-esque methods other than misconfigured services in the exam? No. Is the potato category never fixed? At least not on priority. Cool name pending, at least not on priority. So Microsoft takes their time in fixing potato category of attacks. Is WinPeas a good option for privilege escalation? Yes, I think I've not mentioned it here, but later on I've mentioned that. So any tool that provides you enough privilege, enough coverage. For example, PowerUp, PrivEsc, WinPeas, as Brown Hacker mentioned. So these tools are pretty useful. All right. Do you have a question is, do you have a list of exploits for the manual testing? I do not do for local privilege escalation. I always rely on a tool. It's much faster and covers a lot more than you can do manually. So you can use PowerUp, PrivEsc, and let me skip a couple of slides so that I can suggest some more tools. PrivEsc check, PSNG. You can use any of these tools to check for existing issues. And then you have, as Motorboards mentioned, then you have SITREP tools or situational awareness tools like seatbelt as well. So you can use them to understand more about your foothold or your first beachhead in the target organization. Okay, so what is auto logon? Auto logon is used by industries like advertising, kiosk operators, in hospitals, etc., where you have no one, when you start a machine, you do not have anyone who could log on and start an application. So what Windows provides is, if you set auto log on, then the username and password is stored in the registry. Anyone can read them. And when a machine starts, it automatically logs on. Usually in practice, so there would be an auto log on and an application will run, which an operator can use. Now, if you get access to any such machine, regardless of the privileges that you have, you would be able to read the passwords in clear text. The question was, as a defensive mechanism in an enterprise environment, can we disable NTLM altogether, or will it break anything? It breaks. It breaks a lot of stuff. And that is actually the reason that many organizations who want to turn off NTLM cannot actually turn it off. Yes, exactly as Dubsource says, disabling NTLM is not easy. Too many things still use it. Now, what we are going to do in the lab is we'll have a limited look at the privilege escalation part. We have many interesting things to discuss when it comes to the domain or the Active Directory part. So we will discuss only that stuff that we absolutely require to move ahead with the lab. So what we are going to discuss is service issues. So there are three types of service issues, Windows service issues, that you will find or that you can abuse for local privilege escalation. The service unquoted path. What's that? So all Windows services have a service path. That is the executable that runs as a service. All right. Before I proceed with this, there was a question. Isn't Kerberos an alternative to it? Oh, I would say RC4 is still supported in Kerberos. So usually documents, blogs, papers, and even my slides and I use NTLM and RC4 interchangeably. So when you say disable NTLM in a domain, that means disable the RC4 encryption that can be used to encrypt tickets in Kerberos as well. So that is also an issue when using NTLM. When we say NTLM in domain, that is what it means. Shilpot, that was answer to your question. All right, coming back to this one, all Windows services run an executable. Now, if you look at the path, you would see that a lot of them are unquoted. Some of them are quoted. Literally the quotes here. Right? So we've listed paths of all the services. Now, let's assume this. Let's say there is a service that is installed, that runs an executable that is installed here. Let's call it what, an FTP server. FTP space server. Let's take FileZilla as an example, just as an example. Something like this. All right. Now, if this is the path to a service, this is how Windows services work. If someone can simply go ahead and drop a file ftp.exe here, whenever the service restarts, it is this executable that will run with the privileges of the service. And that is what the unquoted service path vulnerability is. Literally, because the path name was not quoted. If it was something like this, then it would not be a problem. All right. So that is what the unquoted service path vulnerability is. Another issue is the service executable permissions. That is, even if it was quoted, what if you could simply go ahead and replace this ftp.exe with an executable of your choice? Let's say a payload, a metabit, or anything. So that is what the service permission issue is. Or, and the third one is the service permission issue. Now, services have also have ACLs. Services also have security descriptors. So what service permissions issue allow you to is to simply change this. How? Let me show you that. For example, if we take a look at security descriptors of a built-in service. So what are we doing? sc.exe, it is a built-in built-in command. sd show, security descriptor show, and the service name. Now this is the security descriptor of the service ALG. Now let's compare this with, I think we have two vulnerable services configured on student machines, SNMP Trap and Abyss Web Server. So now if you compare this security descriptor of ALG with SNMP Trap, please note that SNMP Trap is a built-in service that is not vulnerable by default, but we have intentionally made that vulnerable in the lab. Excuse me. Now, if you take a look at, if you read this security descriptor, this is allow, this is create child, list child, and other permissions. And this is a well-known SID, system, built-in administrator, authenticated users, and so on. Now, if you take a look at this, what does this WD stands for? WD stands for everyone. So what does this entry means? This entry means that for everyone, it is allowed to have all of these permissions that is equivalent to built-in administrators. All right. And that is what a problem that you can find when it comes to service permissions issue. As PS Valia to you mentioned, access check.exe can also be used for it. However, you would, I mean, for this particular type of issues, that's one of the better tools out there. However, it covers only one way. ICACLs, yes, fast flux. I personally have never used it for it, but I believe it can ICACLs list permissions of services? I'm not sure. If it can, then yes, it would be a very useful tool as well. And I do not recall the name of a tool. There used to be a tool in Microsoft SDK that could be used for setting this up. I do not recall it anymore, but I've used that like years ago. Sub in ACL, I believe, that was the tool. All right, but that's the issue. That is the service unquoted path. If you can drop a file like this and restart the service, this executable will run with the permissions of the service. The service binary issue is if you can simply go ahead and overwrite the executable of the service. And final is the service permissions issue. So how would you abuse the permission issue? You can, in that case, you can simply use sc.exe config snmp trap, let's say, and provide a bin path that is something else, not the expected one. You provide a path to your own executable and then it will execute. All right. Look it up, PS Wali. I do not have a ready reference for that, but if you look it up, there are some Microsoft's own documentations that list that, but I do not have a ready reference for the SDDL. Would this need admin access to configure it? No. Thanks to this entry, we do not require admin access to configure that one. All right. Now, of course, as we briefly discussed a few minutes back, it is better if we hand it over to an automated tool for maximum and faster coverage. So we can run all or most of the checks that we've discussed here using PowerUp, Previous Check, or PSNG, that is WinPs. Using any of these tools, if we find out, and please always make sure that these tools may give you some false positives as well. For example, at least PowerUp gives you this false positive. If there is a service that has a path like this, tools like PowerUp may suggest that this is vulnerable. However, this is probably vulnerable, but practically it would be very hard to abuse it or exploit it. Why? Because you would need, or you would already need, admin privileges to write anything to the root of the C directory. Exactly. So please be aware that you may get some false positives some of the times, but in total, these tools are pretty decent to check for local privilege escalation quickly. Let's talk about some feature abuse of enterprise applications. So a lot of times there are web consoles and applications that are used to manage appliances, printers, applications, and whatnot in any enterprise environment. A lot of third-party tools, that is not only Microsoft tools or your own tools, tools that belong to, let's say, enterprise products from IBM, HP, and whatnot. Now, on Windows, many enterprise applications need either administrative or system privileges. which allow them very interesting for any sort of abuse or exploitation. One such application that you will find even in case of which you may find even exposed to the internet is Jenkins. I mean, Jenkins has come a long way in past few years when it comes to security, a really long way. I mean, I recall, but I think at least till 2017, there was absolutely no authentication. If you know the Jenkins URI by default, there was no authentication required. And companies like Facebook have awarded bug bounties for insecure Jenkins installations, right? And please note that in the lab, we take Jenkins just as an example. We deliberately use an older version of Jenkins, but we take it just as an example of what an enterprise application can lead to. So there are so many tools, a lot of them security vendors tools that require at least system privileges, or they need agents on multiple machines and whatnot. So Jenkins is a continuous integration tool that we are going to abuse. In place of looking for it using port scan, etc., we assume that we know that it is already running on its default port 8080 on the dcorp CI machine, 172.16.3.11. Now, if you have administrative access on Jenkins, you can simply go to this URL, http jenkins server/script, and you can run Groovy scripts there. If the Jenkins master is running on a Windows machine, you will be able to run this as system on the master. However, if you do not have admin access, but you have access to add or edit build steps, we would still be able to run commands on not only on the master, unless explicitly denied, but also on other machines, on other instances. So that is something, I mean, once again, I'm taking Jenkins just as an example. Think of it as a way, any OS command injection on a web console of your choice, or any way where you can execute commands on a Windows machine. Is there going to be Jenkins in the exam environment? No, there is no Jenkins, or in fact, any other similar enterprise application in the exam. Now, all of this discussion brings us to learning objective 5, that is our local privilege escalation learning objective. The first task is to exploit a service on dcorp student X, that is your student machine, and elevate privileges to the local administrator. The second task is to identify a machine in the domain where student X has local administrative access. Please note that we have already done the second task. Right, we used find PS remoting local admin access to find a machine, dcorp admin SRV, in the $corp domain where we already have administrative access. So second task is done already. Third one is to abuse Jenkins to get admin privileges on this server. Let's do the first task, exploit a service on dcorp student X and elevate privileges to local administrator. I believe on my student VM, I already have administrative privileges because I was testing this. So let me remove that first. So I am dcorp student 1. Typo in the name of the group. Net local group administrators. It was the other slash. Student 445. Let me remove that user as well. That is what I was not expecting. Okay, so now I would not have the administrative access. All right. So now we will load InvisiShell because we are going to load PowerUp. And let's run invoke all checks. So what invoke all checks found out was Abyss web server is vulnerable to unquoted service path. Because see, there is a space here in the path, but the path is not quoted. Then service executable and argument permissions, where you can simply go ahead and overwrite the service executable. So in that case, Abyss web server is once again vulnerable. As per PowerUp, even some Chrome services are vulnerable. Neo4j is also vulnerable as per this. When it comes to service permissions issue, both Abyss web server and SNMP trap are vulnerable. Right. So you can see here that both of these are interesting. Why? Because the privileges that they run with is local system, and we have the ability to restart them. Now, in both the cases, invoke all checks suggests an abuse function, invoke service abuse. So let's take a look at the help of invoke service abuse. Now, if we run invoke service abuse just with the vulnerable service name, a new local user called John with this password is added, and then it is added to the local administrators group. Or if you specify a username, it adds an existing user, even a domain user, to the local administrators group. Now, we are, of course, going to use this option. Why? Because this would provide us to run high integrity processes, that is run as administrator. We can use run as administrator option to run services that would, to run processes that would still have domain context. That is, we can run high integrity processes and still have the domain context. So let's run this now. So what I'm running, invoke service abuse, name of the service that I would like to abuse, and the user that I would like to be added to the local administrators group. So you may like to note how invoke service abuse operates. It changed bin path for Abyss web server to this command, restarted the service, and then finally restored the original bin path. So now if you check the membership of the local administrators group, you would see that student 1 is back here. However, I need to log off and log on once to update my access tokens. Please make sure that, I mean, once again, I do not recommend doing the hands-on with me, but if you insist, then have the lab manual open in front of you. Right? I do not pace demonstrations in a way that that you can do it with me. All right, for that, I run 8-hour classes. So there are versions of this class that run 8 cross 5 days, that is 40 hours sessions. It is there where I actually run demonstrations in a pace that you can actually go ahead and try it with me. Right now, we can start. Why do we need to update access tokens? Our new group membership would not be visible in the current processes right now. That's why. Now, the third task was to abuse Jenkins to get admin access on the DCorp CI server. That is where Jenkins master is running. So if we access the Jenkins console here, you could see that we can list people, etc. We can, so there are 3 users here. You can check the build executor status. So it is a Windows Server 2016 64-bit machine. Right now, last tested, I believe it's been at least an year, but last tested, Jenkins does not have by default, if your target instance is using Jenkins' own user database, it does not enforce a password complexity. So you can have even a single character password. Right? So a very interesting way of brute forcing anything like Jenkins that does not have password complexity is to try the username as the password and the reverse of the username as the password, or anything that you can think of. I mean, is the easiest way. So here we are simply going to try. We saw 3 users: build user, Jenkins admin, and admin user, I believe. So let's try for build user, and this is very made up. So please do not, please don't worry if you do not get this in the very first attempt in a real assessment. This is very made up. So build user has the password build user. All right. So now we have access to the Jenkins instance. Our question is, can we extend the labs if you need? Yes, you can check out the announcements channel. You can reach out to the lab team and they will guide you through the process. All right. Now, if you have access to a Jenkins user, please always check if it has the privileges to configure a project. If you have worked with Jenkins, you would know. Otherwise, let me tell you that Jenkins support project-based authorization. That is, your user may not have permissions to configure one of the projects, but it may configure any other project. All right. So here I'm using project 0. You may use whatever project that is not in use. Please note that Jenkins could not build projects in parallel. So please use the one that is not in use. And yes, thanks for reminding that, Jake. Please do not use IE. Use Chrome for this. So if I go to project 0 and go on configure, now this is a good way. If you want to check if let's say there are 1,000 projects on a Jenkins instance, how would you check? if your current user has the privileges to configure builds. Note this URL. Now, using anything, let's say Bob Suite, you can simply replace this project name here and check for the configure option. If you get a 403, you do not have access. If you get a 200, you do have access. All right, so here seems like I have the permissions to configure the build. So let me remove this one. Go to add build step. Make sure that you use execute Windows batch command. Do not use execute shell here. So let's say execute Windows batch command, and we run a simple PowerShell based reverse shell here. So we download invoke PowerShell TCP from the student VM. For me, it is 100.1, and then run it. Let's save it. Now, before I build this project, let me start a listener. Let me start a Netcat listener. You can use Netcat, PowerCat, or whatever you want. And let's build. And I forgot to host, and that's good because many of you might do that as well. So I forgot to host the reverse shell here. All right, and that is why I got a red dot here. Also, please make sure that the firewall on your student VM, either it is turned off or you allow an exception for HFS so that it can receive connections. Let's build it again. And this time we would see that there is a connection from 3.11 for the reverse shell. And here on your listener, in a few seconds, you will get a connect back from DCOP CI as the user CI admin. Now, CI admin is a domain user, and it would definitely be a local administrator because that is the least that Jenkins requires. Is HFS something like Python simple HTTP server? Yes, it is. It is. It's just GUI based, so a bit easier to use. I mean, of course, if you're not scripting stuff. A question is that we're using a modified version of invoke PowerShell TCP. Will this be placed on your GitHub, or that is on my GitHub? No, we won't. I mean, that's the reason I'm using it in the class. The difference is very minor, but as soon as I'll put it on my GitHub, it will start getting detected again. So that's why. I mean, to be honest, gone are the days where you can pick up the tools directly from GitHub and use them without modification. We have to make at least some minor modifications. A question is, what does the use basic parsing option do? So that is required if if your target machine has never ever run Internet Explorer at least once, you will get an error that Internet Explorer engine has not been initialized or something like that, because invoke web request uses that in the background. So if you use that, you won't face that error. Why are we using port 443? Because that is usually allowed across firewalls. All right. So that was our third task of learning objective 5. Now let's talk about Bloodhound for domain enumeration. So Bloodhound is a very, very useful tool for penetration testers and blue teamers. A bit noisy to be very useful for red teamers, but if you use it smartly, then very useful for red teamers as well. So what Bloodhound does is it provides you a very nice graph-based visualization of an Active Directory environment. It provides you a snapshot of the current state of Active Directory. You can run queries on that data, find out paths, map attack paths, check details, and once again, you can easily visualize how can our environment be compromised, right? So there are built-in queries in Bloodhound for frequently used actions, and also it also supports custom cipher queries. So to absolutely utilize Bloodhound to its 100%, it would be better if you know cipher. So there are two components to Bloodhound. One is the collectors or ingesters. That is the part that you are supposed to run in the target environment. Please make sure there is absolutely no need to run the Bloodhound GUI in the target environment, and that holds true even for your exam. There is no need to set up the Bloodhound GUI on the exam, on the student VM in exam, right? Please keep a Bloodhound GUI ready on your host machine and just run the ingesters if you plan to use Bloodhound in the exam. So we can either run the PowerShell-based ingester or collector or sharphome.exe. Both of them will generate a zip archive that we can then upload to Bloodhound GUI for analysis. To avoid detection using tools like Microsoft's Defender for Identity or ATA, we can use the exclude DC. If you use the exclude DC option, then certain tests like session enumeration is not run against the DC. All right. How would you use Bloodhound smartly on a red team? A very good question, to be honest. First would be not using the collection method all. That's very noisy, because that also includes looking for local administrative access on other machines. Also, it would always make sense if you run it from if you have, let's say, a patsy user, a proxy user, or a throwaway user that you are ready to sacrifice, then that is something that you can also use. Other than that, this is going to be pretty noisy. What is this? ATA is a tool from Microsoft, Advanced Threat Analytics, which is now known as Microsoft's Defender for Identity. Tools like these are designed to detect Active Directory-based attacks. So once we have a zip archive created by the collector, then we can upload it to Bloodhound GUI and analyze stuff. Now, learning objective 6 is set up Bloodhound and identify a machine where student X has local administrative access. Make sure that if you want to practice, or let me rephrase this, if you want to absolutely utilize the lab to the max, make sure that whatever the enumeration we are going to do henceforth, or something that we have already done, you try it using Bloodhound as well. Right? Unless you are absolutely doing this class for the certification, the most value you will get is if you spend more time in the lab. Also try to troubleshoot stuff. You learn the best when you troubleshoot stuff. I'm not asking you to troubleshoot lab access issues, but let's say if you want to check, okay, let me see if Bloodhound does that or not. Go ahead and check it in Bloodhound's documentation. That is the way. You will learn a lot. If I use Bloodhound in Kali, the collector needs to always be run locally at a Windows host. I would not say that you need to run it locally, but you need to run it against. I mean, you need not run it on a Windows host. If you have the credentials, if you have a domain user's credentials, you can run it even from a Kali machine. I do not have the link handy, but there is a Bloodhound ingester written in Python as well. So there is no need to absolutely run it on a Windows machine. A question is, local admin privileges means running services as administrator on a specific machine. I would say at the in very simple terms, local admin privileges means you are a member of the local administrator's group on a machine. All right, now let's run Bloodhound here. Let's leave this reverse shell running because we are going to come back to this in the next hands-on, the next learning objective. So let's start NVC shell here. Go to the Bloodhound collectors directory. And let's load sharphound.ps1, the collector. And finally, we will run the collector with all collection methods. It takes its own sweet time, a couple of minutes at max though. So meanwhile, we'll not wait for it. I already have the data uploaded to the Bloodhound instance on my machine. Now we'll run the GUI. The password in the lab is, username is Neo4j, and the password is Bloodhound with B and H in uppercase. You will find this in the lab manual as well. So you can see the data. This is what the data has captured. And then if you go to the analysis tab, there are pre-built queries, or you can run a Cypher query from here. So let's run the first one, find all domain admins. So there are just 2 domain admins, as we already know. Find shortest path to domain admins. So what is the shortest path to domain admin? Once again, please keep in mind that Bloodhound captures the current snapshot. All right, so something that you, for example, specifically these has session links that may not hold true once when you try to abuse them. Right? Now, what is the shortest path to domain admin? One of the shortest path that Bloodhound is showing is the user student 449, who is a member of the RDP users group. Now, RDP users group has admin access on dcorp admin SRV machine. dcorp admin SRV has constrained delegations set on dcorp DC. And once you are on the DC, then you can get domain admin privileges. All right. I'll pick up the questions in a minute, in a moment. What else do we have? We can map, for example, domain trusts. So our current domain has trust relationship with Money Corp, with US.Dollar Corp, and Euro Corp. Please note that not only, of course, just wanted to make sure that you know that not only with for the current domain, you can specify a trusted domain or a forest as well. So if you run, for example, this eurocorp.local, you'll get to analyze the data for that forest as well using Bloodhound. So if I upload the data for eurocorp.local, all right, and now if let's say I say find all domain admins, now it shows us results both for Dollar Corp and Euro Corp. All right. Now, other than the pre-built queries, you have path finding as well. So let's say I want to check if there is a path from student 1 to, let's say, the SVC admin, one of the domain admins. So there is actually a path. What's the path? My current user is a member of RDP users, the same one that we saw earlier, right? That has administrative access on DCorp admin SRV, that has constraint delegation on DCorp DC, and from there you can go to SVC admin. Now, and as I said, spend some time, play with it. It is a fantastic tool, very useful. Now, what we are tasked is identify a machine where student X has local administrative access. So for me, student X is student 1. So let me select that and get some node info. So there are some interesting properties here. What we are interested in right now is local admin rights. First degree local admin rights on DCorp student 1. Derivative local admin rights on DCorp admin SR, thanks to our membership of the RDP users group. And this is what we also confirm using find PS remoting local admin access. All right. Now I can pick some questions. One question was, you mentioned something about Bloodhound in the exam environment. Is it necessary to run directly on the student machine? How should we utilize this? I said that there is no need to use the GUI that you're looking at right now. There is no need to set up this GUI on the student VM. To run Bloodhound GUI, you would need JRE, Java Runtime Environment. You would also need Neo4j database. So do not waste time in trying to set up that on the student VM during the exam. Instead, keep one ready on your host machine and just run this part. The data collection part, just run that on the exam VM. That is what I said. Another question was, Bloodhound can directly pump data into the database. Would it make sense to use that versus files on disk? I would not say that it would be more useful. The reason is that because for that, you would need to have the Neo4j database right there. Probably here you can play with it, but not in a real world environment. Another question is, are we running this on the reversion? No, we are running this as the normal user on our own student VM. All right. So are the trusts not shown? Okay, let me check that. The question is, it doesn't specify whether the trusts are bidirectional or not. I think the arrows will show that. Is that so? You can see that there are two trust relationships here. It is a bidirectional trust. Dollar Corp trusts Money Corp and Money Corp trusts Dollar Corp. Would there be any value on running it on the reversion? A very good question. So does it make sense to run all the enumeration whenever you compromise a new user or a machine? So the answer is both yes and no. Yes, it makes sense because a new user may have administrative access on new machines. A new machine may have network access to other machines that are not accessible from your foothold. So it makes sense, yes. However, a lot of information, specifically the one that is gathered from the domain controller, like users, groups, sites, ACLs, trust relationships, that are the same, regardless of what are the privileges or the machine that you are running this from. So unless you want to run very specific targeted queries, you would be fine with running this just once from a machine. All right. Let's move on to the next topic now. Let's talk a bit about partial remoting. You can think of partial remoting or PS remoting as PS exec on steroids, but much more silent and super fast. So PS remoting uses WinRM. WinRM is Microsoft's implementation of WS management, which is an industry standard for inventory management. Now, WinRM is enabled by default on Server 2012 onwards, with a firewall exception added to the Windows firewall. PowerShell remoting listens, or WinRM listens by default on port 5985 for HTTP and 5986 for HTTPS. So the transport protocol used by WinRM is HTTP or HTTPS, depending on the settings. Partial remoting is the recommended way to manage Windows core servers. Please note that it is not enabled by default on the desktop OS like Windows 10, 11, etc. Now, when you PS remote or WinRM to a remote machine, you get a high integrity process. That is, you get an elevated shell. There is no USC issues when you use PS remoting or WinRM. Now, partial remoting is of two types: one-to-one, that is from one machine to another machine. It is interactive, runs in a new process, WSM provost on the remote machine. Note that it is not PowerShell.exe that starts on a remote machine when you PS remote into it. It is WSM provost. You can use command nets like new PS session and enter PS session for that. So if I start a PowerShell session here, recall that we already have administrative access on dcorp admin SRV. Like WMI and PS exec, you must have administrative access on the remote machine to use partial remoting. So I can use enter PS session, computer name, dcorp admin SRV. And I can now interact with the remote machine, dcorp admin SRV. And we are running inside the process WSM provost. All right. Now you can run commands as if you are on that particular machine. WinRM or PS remoting is a logon type 3. You can also store a PS session in a variable, something like this. Now we can simply use enter PS session $admin SRV, or if you really want, if you're a purist, then session $admin SRV, and we will be into that session. The variable $admin SRV right now holds the session to that remote machine. Now this is cute, but how would you use it against, let's say, I mean, as attackers, we may not be used to running commands on 10,000 machines because we are trying to stay low. But administrators need to run commands on thousands of machines. So if they are going to do it like this, that will definitely take ages. So for that, there is one-to-many partial remoting as well. That is fan-out remoting. This is non-interactive. That is, you do not get an interactive shell. And the best part is it executes commands parallelly. The useful commandlet for that is invoke command. I'll come back to this slide in a moment. For example, if you want to run simply the get process commandlet, let's say on 50K machines, you simply run invoke command dash script block, specify your command here, and then pass a list of servers, and invoke command will run this command specified in script block parallelly on those 50K machines, assuming you have the privileges to do so. Now, because of this, PowerShell invoke command is the best way to test scripts, regardless of them being offensive scripts or defense scripts on a large number of machines. All right. You can not only run commands, but you can also run local scripts on remote machines. So what happens when you run this command? This get pass hashes is converted to a basic 64 encoded script block and is run parallelly in memory of WSM prov host on all the machines that you specify here. And that is a built-in functionality, which makes it, as I said, very, very useful for running scripts parallelly on multiple machines. Not only commands and scripts, you can also run locally loaded functions on remote machines. Invoke command also accepts session parameter. So if you want to run stateful command, let's say you want to load a script and then interact with it in an interactive session, you can use the session parameter as well. So this makes partial remoting very useful for a lot of lateral movement. However, partial remoting, just like PowerShell, supports system-wide transcripts and deep script block logging that we saw earlier. And we have been using InvisiShell to avoid that. So what are our options now? I mean, PowerShell remoting looks exciting, but it supports deep script block logging and system-wide transcripts. If you suspect that your target organization is actually looking at this stuff, then you can use WinRS in place of PS remoting. So you would still reap benefits of port 5985 and 5986 being allowed between hosts, and you would evade the logging of PS remoting. So WinRS or WinRM.VBS or COM objects of WSMin, all of these would provide you similar results. Right? That is what partial remoting and WinRM is. Just give me a second. Now, when we are talking about lateral movement, because now we have administrative access to a couple of machines in the target domain, we can start thinking about lateral movement. I mean, of course, that is why we talk partial remoting. Let's talk about mimicards. So mimicards can be used to dump credentials, tickets, and whatnot from a Windows machine. Invoke mimicards is a partial port of mimicards. It reflectively loads mimicards binary in memory of partial process. So mimicards is one of the tools that single-handedly changed the Windows security scene totally. So it was released in 2012, June 2012, when mimicards was publicly released. And I would say there is a different era. There was something else before 2012. Windows security was something else before 2012, and then it became something else after it. Attacks like golden ticket or CD history injection and the likes were always known, but this tool actually brought those attacks to everyone, and that actually helped in improving security of Windows and Active Directory a lot. And there is a very interesting story on how mimicards was released, right? I mean, you can check it on Wired. Wired did that story a few years back, and it was amazing. I mean, interestingly, I was speaking at the same conference. It was released at a conference in Moscow called PH Days, and I never got a whiff that what was happening and why Benjamin released it right there at PH Days. Look it up there. Look up. Someone may like to look up that Wired article. It's amazing. The story is very interesting. All right. Now, however, invoke mimicards is one of the most widely, as we discussed earlier, while talking about invoke mimicards and how we can make it a bit less detectable. It is one of the most widely detected scripts. So what are our options then? There are different variants of mimicards. Of course, there is invoke mimicards. Then we have safety cards that creates a mini-dump of LSS and then runs a PE loader to run mimicards on it. Then we have sharpcats that has some functionality of mimicards in a C# port. We can also use tools like dumpert. So now we are looking at ways of extracting credentials from LSS. We can use tools like dumpert from Outflank that uses direct system calls and API unhooking for extracting credentials more silently. We can also use PyPyCats that has mimicards functionality in Python. Because it is Python, you can run it both on Windows and Linux. You can also use tools like comsvcs.dll with rundll32. So both the DLL, comsvcs.dll and rundll32.exe are Microsoft signed. So you can use them to avoid some application allow listing solutions. If you are running, if you're trying to extract credentials from a Linux machine, then you can use Impacket. You can also use FISMEM2Profit. You can also use LSSE and a lot of other interesting tools. Extracting credentials from LSS is the peak of cat and mouse game that attackers and defenders, or rather offensive tooling companies and individuals versus EDRs play. So this is the classic cat and mouse game. A new tool would suppose, or a technique would supposedly work for a few weeks or months, and then it would start getting detected, and then something new will come up. So that is the cycle that keeps going on. Now, once you have the credentials, how would you use them? You can use overpass the hash or OPTH to generate tokens from hashes or keys. So how is overpass the hash different from pass the hash? Pass the hash allowed you to access resources that accept NTLM authentication. That is, let's say you have the hashes of the local administrator. You use pass the hash to access another machine that has the same password as that local administrator. However, if you have, let's say, an NTLM hash or AES key of a domain user, you can use overpass the hash to create a token for that user and access domain resources using that. That is what the overpass the hash attack is. Now, you can use invoke mimicards or safety cards or any of its variants. Please note that both the above tools start a process with a logon type 9, same as run as net only. What is logon type 9? Logon type 9 is new credentials are used only for accessing network resources. All right. Once again, what is overpass the hash? If you have access to NTLM hash or AES key of a domain user, and you would like to access a Kerberos resource like a domain joined machine using that, then you can use overpass the hash. In case of pass the hash, you are able to access only the services that support NTLM authentication, that is only local resources. Now, both of these commands need elevation, that is, you need to run these from a high integrity process. But if you run this from Rubius, you do not need elevation. However, this command overrides the, just give me a second. So it is pretty cold in my city right now. I mean, by Indian standards, it is pretty cold. And I'm not used to this much cold. So I just grabbed a blanket. Right? So 7 degrees, I believe, right now. Thanks. Oh, wow. Yes, yes. I mean, I want to do not trigger me in talking about weather. So whenever I'm in Europe, let's say I used to before this COVID stupidity struck everyone, I usually I would be during summers, I would at least be at BrewCon, and Ghent would feel warm on 8 degrees or 9 degrees. And then I mean, my students, out of not sounding racist, they won't say anything, but they will say, dude, you are from India. So is this not like winter for you? But no, your body adapts really, really fast. And I feel warm there, even at 8 degrees, and I'm feeling cold here at 7 degrees. Okay. So here, coming back to this one, if you run this command, the first command of Rubius, it overwrites your current tickets, but doesn't need elevation. But if you want to start a new process using Rubius, then that needs elevation. Finally, one more technique that we can take a look at when talking about lateral movement is desysync. Now, if you have enough permissions, by default, only domain admins and other high privileged groups have that. But if you have enough permissions, you can actually request credentials for any users from the domain controller without having to run code on that. And that attack is called the desysync attack. Recall one of the 4 components that we discussed on day 1, one of them was replication service. So here, if I run this one or this one with the domain admin privileges or with privileges of any user that has enough permissions, then we would be able to get the credentials of this user. So yes, we talked about different tools that we can use for overpass the hash. Now we're talking about a technique that we can use to request credentials from the DC without having to run code on the DC. Right? Are Rubius and Mimikatz noisy? I would say those are pretty popular tools. So as far as detections from AV and EDR are considered, yes, they are noisy. Right. So that's it. Now we've seen some .NET tools here in this list. All right. Like safety cards, sharp cards, etc. So now is the time where we can have a quick discussion on offensive .NET. Now, currently, .NET lacks some of the security features implemented in PowerShell, that is system management automation. Now, because of this, included or re-included .NET in their tradecraft. Also, at least till last year, I mean, now the cool offensive tooling community has moved on to other languages like, let's say, Rust or NIM or Booleang or IronPython, etc. But at least up to last year, and when I say last year, I say 2020, .NET was cool to name your tool sharp something, sharp insert name of the tool, right? So now there are so many offensive .NET tools that of course we cannot discuss all of them. So we will use the ones that fit our attack methodology and check if we can make at least some modifications to bypass Windows Defender. Similar to what we did for the PowerShell tradecraft, what we are going to take a look at is when we are using .NET tools, there are some challenges that we need to address. First is detection by countermeasures like AV, EDR, etc. Second, delivery of the payload. Recall that PowerShell has a built-in capability to download and execute scripts in memory. Third is detection by logging, for example, process creation logging, command line logging, sysmon, etc. So what we will address is the AV detection, and that too for Windows Defender only. The simple reason for that is no matter how much I discourage people go ahead and upload stuff to VirusTotal that I share in the class. So I do not want to be a part of that cat and mouse game where we keep maintaining executables that are not detected. So if any of the binaries that we share are detected, then you would be on your own. Please keep that in mind. As I said earlier, that is not our focus, absolutely not. I mean, I don't know how and why people get away with that. As an organization, we are not supposed to teach you how to bypass EDRs. That would be licensing violation. And because we are a sizable company now, that, I mean, that's a big no-no. We cannot, even if I want to, I cannot share EDR bypasses without repercussions. I mean, that's nothing that is of interest. I mean, I just was telling why we do not discuss AV EDR bypass. And it is a pain, it's a PETA. To bypass an EDR properly, there is no one size fits all bypass for EDRs. Rarely there is one. So you have to be very specific with your techniques. Coming back to this one, as I said, we will focus on Windows Defender. And we will target only not only signature-based detection, but most of it would be signature-based detection. However, as you will see later on, when it comes to Windows Defender, we will also address behavior-based detection. So just like we used MZ check earlier, we will use Defender check here. This identifies code and strings from a binary that Windows Defender may flag. For example, if we pass shortcuts to defendercheck.exe, it complains about this. Now, defendercheck.exe that we have used in the lab does not exactly tells you which string it has problems with, but usually that is at the end of the block. So by some trial and error, we will get to know that it is the credential string that Windows Defender has a problem with when it comes to shortcuts. So a simple string manipulation is we replace the string credentials with credents, rebuild the entire solution, and check it again with Defender check, and it would be fine. A lot of times, static detection is that easy to avoid. Similarly, for safety cards uses an embedded version of Mimikatz DLL. So what we did to bypass or avoid Windows Defender for safety cards, we downloaded latest version of Mimikatz, passed it through out-compressed dll.psn from PowerPoint. You can find the links in the slide notes. And then used that compressed binary in this one, in the constants.cs file of safety cards. Then change the byte size on the following lines because it is a different size now, and rebuild it. For better safety cards, but what better safety cards does is it downloads the latest version of Mimikatz from Benjamin's GitHub repository and uses it. So downloading anything from within an executable may also flag some behavior-based detection. So in place, what we did was we downloaded the latest release of Mimikatz, converted that to a base 64 value. And in place of the default detection of better safety cards, not detection, the default action of better safety cards of downloading it from a URI or from a path, in place of that, we passed the compressed zip stream, made changes to the program.cs so that it reflects, and rebuild it. The last one was a battering ram approach for Rubius. So in place of rebuilding Rubius, we used ConfuserX to simply obfuscate the whole compiled binary. I mean, we compile it as it is, and then obfuscated it using ConfuserX. And these are the steps that we followed. So these are more of reference slides. And then we could bypass Windows Defender. Please keep in mind for all of these tools, if you look at the C80 tools directory on your VM, there are, for example, if we look for safety cards, there is a tool called safety cards, and then there is safety cards old, or a safety cards repository. If I can find it right now. Or let me show that that for better safety cards. So this archive is the better safety cards that is publicly available, that is from its GitHub. And the one that you have here, this one, is the one that we created. Why? So that if you want to reproduce these steps, you can do so. So this way we address the basic detection for Windows Defender. A couple of questions. Would you have to do this in exam? So the Windows Defender signature would not be newer compared to the lab in the exam. So if you can bypass Defender in the lab using the tools that we have, you would be able to do so even in the exam. Sorry. Now, the second hurdle or issue that we want to address is the payload delivery when it comes to .NET. Recall that in PowerShell, we could simply use download execute credits. Do we have anything similar in .NET? Something like execute assembly in Cobalt Strike that people are a fan of, and it is a very interesting technique. So we can use NetLoader to deliver our binary payloads. So what NetLoader does, or its minor modified version loader.exe that we have in the lab, it can be used to load binary from a file path or URL. It patches .NET MZ and event tracing for Windows, ETW, that is used by a lot of EDRs as well. It patches both of them and then loads the binary in memory of loader.exe. We also have a custom assembly load.exe that can be used to load loader.exe in memory, and then loader.exe can call a .NET assembly and run it in memory. However, this also results in a behavior-based detection and executable downloading stuff from a remote web server. This is something that a Windows Defender doesn't like. So we have to make some changes to bypass this detection. That is something that we'll try in learning objective 7. So now we have to identify a machine in the target domain where domain admin session is available. We need to compromise the machine and escalate privileges to domain admin using two methods: using access to dcorp CI, and second, using derivative local admin access. Let's try it. So let's first try it using dcorp CI. We have a reverse shell on dcorp CI that we got by abusing Jenkins. Now, we have been absolutely careful in bypassing enhanced logging and MZ by using InvisiShell. However, because InvisiShell is a DLL and we do not want to use reflection right now to load it, let's bypass script block logging and MZ here. So if you look in the C80tools directory, you have a text file called SB logging bypass that is an obfuscated version of a publicly known script block logging bypass. So let's run that. Remember to host that on your HFS or simple HTTP server, whatever you're using, right? Then we can use this MZ bypass. You can use it in a file as well, just like script block logging. Then we bypass MZ. Please note that we first bypassed or incapacitated script block logging so that our MZ bypass itself is not logged. Now, finally, we can download and execute PowerView in memory of this reverse shell, once again from hosted in our HFS. Now, we need to identify a machine where a domain admin session is available. What was the function or the command that we saw can do that? Find domain user location. This will take some time to run. So now what happens when we run this? A request from dcorp CI as CI admin goes to the DC, requests a list of domain admins, membership of domain admins, and a list of computers. Now this will go to each and every machine in the domain and request or tries to list sessions and currently logged on users on that machine. If that matches membership of the domain admins group, we'll get a result here. The question was, do tools like NetLoader exist in PS1 format? I believe, yes, there are some tools that can load .NET assemblies in memory of PowerShell process. I remember looking at one. I do not recall the name. So that uses reflection assembly to do that. I can look that up for you though. So okay, this takes its sweet time. So if it doesn't come back, let's say in 5-10 seconds, I'll simply kill this and we'll assume that we got some result. Now, what is the expected result here is we'll get to know that there are two machines where sessions of for domain admin are available. One machine is dcorp MGMT and another one is dcorp FSR. Now we will check if we have admin access on any of the machines by running some WinRS commands. All right, so here you can see that we have session of SVC admin on dcorp MGMT and session of the administrator domain admin on dcorp FSR. Let's target this one first. So I'll simply try to run a couple of commands. Please note that we are repeatedly using who am I here, but that is not the very best command to run on a machine. A lot of times, because this is used by attackers a lot as well, a lot of times even that may lead to detection. So because we can run WinRM commands, it is safe to assume that we have administrative access on dcorp MGMT as the CI admin user. However, please note that we do not have direct access to dcorp MGMT. Now, one way, if you see the lab manual, one of the ways is to load invoke mimikatz here in memory and then run it on dcorp MGMT. But what if you would like to run that loader.exe on dcorp MGMT? We have to download it locally on dcorp CI. Yes, we have to touch disk. But because we are using a modified version of loader.exe, it won't be detected by the defender. So we downloaded loader.exe and saved it to this directory. Now from here, because as CI admin, we have admin access to dcorp MGMT, let's copy loader.exe from dcorp CI to dcorp MGMT using xcopy. Okay, so it is already there. Now, the behavior-based detection I was talking about. If I run this, I'm not going to run that. If I run this command now, that is using WinRS on dcorp MGMT, if I run loader.exe like this, so if I run loader.exe like this, it will lead to a detection. Why? Because an executable would be trying to download another executable or anything from a remote web server. So if I run this, this leads to a detection, a behavior-based detection by Windows Defender. So how do we avoid it? A very easy way, easy but smart way, is to use port forwarding. So what does this command does? This $null is simply to avoid an issue with output redirection. There is no any other significance of this. What we are doing using NetSH, a built-in utility on Windows, we are simply forwarding port 8080 on dcorp MGMT to port 80 on the student VM, on my student VM. For me, it is 100.1. So after running this, now if I run the command where I'm downloading safetycards.exe from a local address, not a remote one. In this case, there would be no detection. Let's run it. As you would see, there is a connection from 4.44, that is tcorp mgmt. And as you could see, we actually extracted credentials. Now, what are the credentials that we want from tcorp mgmt? It is for the SVC admin. What is SVC admin? A domain admin. Why are we able to extract credentials even in clear text for this user? Because it is in use as a service. What does this service from zero means? This means that SVC admin user is used to run a service on the tcorp mgmt machine. All right. So that was our first task. Compromise a machine where domain admin session is available and escalate privileges to domain admin. All right. Now, we won't use the clear text credentials right now. What we would require or what we would copy is the AES key and the NTLM hash. Oops. We can exit from this shell. Now, recall we discussed overpass the hash from an elevated shell now. We can use this overpass the hash command. What is the command? We want to use Rubius, ask TGT module from Rubius. The user that we want to start the process as is SVC admin. This is the AES 256 key that we copied. We want it to be OPSEC safe. That is, no need to use NTLM hashes. We want to create a logon type 9 process, cmd.exe, and we want to interact with it. And we want to pass the ticket right away into that process. So this process runs with the privileges of SVC admin. However, please note this. If you run who am I, it would still show you student 1. Why? Because this is logon type 9. In logon type 9, new credentials are used only when you access network resources. What are some network resources that we can access as a domain admin? The DC, right? I mean, not really recommended, but works very well as something to demonstrate. All right. And that is our first privilege escalation to domain admin. Any questions? So if this seems overwhelming, I mean, it is fine. We executed multiple attacks here. We bypassed AV, we extracted credentials, reused them. So it is absolutely fine if this seems overwhelming. Rewatch this, practice. And as I was saying earlier, when you practice this, then you will get to know that, okay, this is not as complex as it seems. All right. Now, the second path using derivative local admin is something that I'll circle back to once I've discussed some persistence methods, because this includes discussion on allow listing. So we'll come back to this when we have, let's say, 7 minutes left of the session, we still have 32 minutes for the session. Now, once we have domain admin privileges, we can start looking at true domain dominance. So there is a lot more in Active Directory than just the domain admin. Once we have the privileges, we have a lot of avenues or opportunities for persistence. We have opportunities to escalate to EA. We can run attacks across external trusts and whatnot. So let's first have a look at abusing trusts within, let's first have a look at persistence. And for that, we first need to know about Kerberos. Now, what is Kerberos? Kerberos is the basis of authentication in Windows Active Directory. So in Kerberos, clients, that is programs on behalf of a user, need to obtain tickets from KDC, which is a service running on the domain controller. These tickets represent client's credentials. Because Kerberos is the de facto authentication mechanism, it is, of course, very interesting target. So what does Kerberos look like? Or how does Kerberos work? Let's say you, that is a client or a process or a thread on your behalf, wants to access a service on this application server. This is how the authentication and authorization will work. Your client will send a timestamp that is encrypted with the hash or key of the user's password and send it to the DC or the KDC, the key distribution center. Because the DC has access to all the secrets in the domain, it will decrypt the timestamp and respond with a TGT. Now, when the DC at the end of step 1, when the DC decrypts the timestamp, it completes the pre-auth part. That is, it verifies that the request actually came from the user that it claims to be from. Now, responding to that, the DC sends a TGT. Now, a TGT is encrypted and signed with the hash of a special account on the DC called the KRB TGT or Kirby TGT account. Now, at the end of step 2, the client receives the TGT, but it cannot decrypt that because it does not have access to the secrets of the Kirby TGT account. Now, the client presents the TGT back to the DC as a proof of possession and requests access to this application server or specifically to a service. It requests a TGS or a service ticket. Please note that TGS, the actual name of the ticket that the service requests is service ticket, but TGS is also used interchangeably and I prefer that. So the client presents a TGT and requests a TGS for the service hosted on this application server. Now, at the end of step 3, the only validation that the KDC does is if it can decrypt the TGT. Once again, the only validation that the DC does is if it can decrypt the TGT. If that is validated, whatever is written inside the TGT is considered to be correct. Now, once that is validated, the DC responds with a TGS. As I said, TGS is a service, but the word TGS is interchangeably used in documentations and books, as this is sometimes called TGS, sometimes it is called a service ticket. So the DC responds to the TGS that is encrypted using secrets or NTLM hash of the target service account. End of step 4. Can the client decrypt the TGS? It cannot. So it presents the TGS to the target service. Can the target service decrypt the TGS? Yes, it can. Why? Because it is encrypted using its NTLM hash. So the service then decrypts the TGS, and then it is the service that decides on the privileges of the user on itself. The DC has no role in authorization unless the optional PAC validation is turned on. And there is also an optional mutual authentication, which I have never seen turned on ever. Both the PAC validation and optional mutual authentication. This is how Kerberos works. All right. Please make sure that you understand this very well. We will keep coming back to this diagram and the Kerberos functionality again and again. Right. Now, this is how Kerberos works, and almost each step in this diagram is abusable. All right. And as Goran Ree pointed out, when the timestamp is decrypted at the end of step 1, clock skew, recall when we looked at the Kerberos policy in session 1, the default clock skew is 5 minutes. And that is what is also checked here to complete the pre-auth part. Now, each step here is abusable in one or the other. What we are going to look at, we'll come back to this slide in a moment. What we are going to discuss right now is the golden ticket attack. So recall, I emphasized here that at the end of step 3, the only validation, and I say that deliberately with a lot more accent so that you remember that well, the only validation that the DC does at the end of step 3 is if it can decrypt the TGT using Kirby TGT hash. That is it. Whatever you write inside the TGT or whatever is written inside the TGT is assumed to be correct if the DC can decrypt it. That's it. That is the only validation. That is the source of truth becomes the TGT, or rather not the TGT, the Kirby TGT hash. What does that mean? That means that if you have the secrets of the Kirby TGT account, you can skip the first 2 steps. You can forge or create your own TGT here, present it to the DC, and if the DC can decrypt it, that is the only validation it does, it will accept whatever is written inside it. So if you write inside the TGT that you are the domain administrator of the current domain, the DC will validate that and accept it. If you write that you are the enterprise admin for the current forest, the DC will accept that and validate that. And that is what precisely what the golden ticket attack is. A golden ticket is signed and encrypted by the hash of the Kirby TGT account that makes it a valid TGT. In fact, because by default for first 20 minutes, though no user validation is done, so you can actually create a TGT for a non-existent or deleted or revoked account as well. Once you have the secrets of the Kirby TGT account, you can create a golden ticket even from a non-domain joined machine. All you need is access to Kerberos port 88 on the DC, the network access to it. That's it. Uh, it is now recommended by Microsoft to change the password of the Kirby TGT account twice, not once, because password history is maintained for the account. Now, why is this attack very dangerous? One, it gives you domain admin access instantly. Second, and it also answers your question, forbidden network. What is the longevity? What is the validity of this ticket? It is valid as long as you do not change the password of the Kirby TGT account twice. Microsoft recommends changing it every 6 months, I believe. Most of the organizations still today in 2022 never change it. And if they change it, it would be, let's say, what, once a year. So that is what it is. Very long persistence. You can definitely count it in months, if not years or decades. Password of the Kirby TGT account, that is something that you should regularly change. That is the account whose secrets are used to decrypt and encrypt a TGT. All right. Now, how do you create a TGT? Mimikatz. So once you have access, so we need to run the first command as a domain administrator to be able to extract the secrets. Once you have the hash of the Kirby TGT account, you can run this command or any of the Mimikatz variants from any machine that can reach the domain control over the network, and it will create a TGT for you. Let's take a look at the breakdown of the command. So Mimikatz, invoke Mimikatz or any of its variants, the module is called Kerberos Golden. That's the name of the module. The user that you would like to impersonate, please absolutely keep this in mind. Because user validation is not done for first 20 minutes, you can use anything here. I mean, you can use who's your mama here, and that would also be accepted. However, that would light up a SIM device like a Christmas tree. You would definitely be detected. So don't use that. So don't use that, right? Also, please keep in mind that the user that you specify here matches the RID that is specified here. By default, Mimikatz picks 500. So if you are specifying any other user here, then make sure that the ID matches. Next comes the FQDN of the target domain, SID of the target domain, secret of the Kirby TGT account. This is the NTLM or RC4 hash. It is recommended to use AES 256 key and not the RC4 to avoid detection from tools like MDI. All right. Then comes the /PTT or /ticket. /PTT injects a ticket in the current PowerShell process. /ticket saves the ticket to a file for later use. I once again recommend this to avoid detections based on the time taken by the validation time or the validity of the TGT. So make sure, and recall we enumerated active users by looking at the logon count. Make sure that you always use an active domain administrator here. Do not ever use a stale domain admin here. Because you will leave a 4624, a 4634, and 4672 on the DC when you use a golden ticket. When you use a golden ticket, not when you create it. The more options that we discussed earlier was make sure that your TGT complies to the ticket lifetime settings of the target domain. By default, Mimicards creates a ticket that is valid for 10 years and can be renewed for 10 years. So there are detections, there are tools that detect specifically on that thing. So make sure that you specify it based on the Kerberos policy in the target environment. All right. And that is it about golden ticket. Now, if you want to extract the secrets by not running code on the DC, you can run DC sync as we saw earlier to get the credentials of the Kirby TGT account. And this brings us to our learning objective 8. Extract secrets from the domain controller of $corp using the secrets of the Kirby TGT account, create a golden ticket, and then get back your domain admin privileges. So let's quickly try this one. So here we have a process that is running as a domain admin. So first, we will extract the secrets of the Kirby TGT account. That is the first thing that we are going to do here. So we can either run a command on the DC, or we can use the DC sync command to extract the credentials of the Kirby TGT account. Let's use DC sync here. Just like that. Because our current process is running as a domain admin and domain admin has the privileges to run DC sync, what we did using safety cards, we ran the DC sync command and we requested credentials of the Kirby TGT user. And of course, we got them. That's the AES key of the Kirby TGT user. That's the AES 128 key. And this is the NTLM hash. Now, as I said, we would be more interested in AES 256 key. So let me copy that. And how do we now create a golden ticket? We can simply, we do not need any special privileges for a golden ticket. However, the tools like better safety cards or safety cards that we are going to use to create golden tickets, they check if they are running from a high integrity process. Therefore, we'll run that from a command prompt that is running as a local administrator. Note the AES 256 key is the one that we've copied. Let's run this. If you run klist here, you would see that we have a TGT for the domain administrator now. Now you can simply go ahead and access services on the DC. Please note that if your target is server 2016, you would not be able to use WinRS or PowerShell remoting after using a golden ticket or a silver ticket. However, you can still run commands using WMI. Right, so we simply ran this class on DCORP DC. WinRS or PowerShell remoting. If you use WinRS or PowerShell remoting here, you will get an error like this. So this works fine with server 2019 and then later, but if the target is server 2016, you will face this issue. Just with golden tickets and silver tickets. As we saw right here with overpass the hash, it works absolutely fine, as we saw here. Is DC sync a misconfiguration in DC? No, it is a feature, replication service. It's not a misconfiguration. Works with that as well, GOF23. Now, another attack that we can talk about is silver ticket attack. So if we go back to our Kerberos diagram, previously we abused step 3 and 4. Here we are going to abuse step 5. That is, if we have access to the secrets, let's say NTLM hash of the service account or AES key of the target service account, we can create a TGS and present it to the application server without having to interact even with the DC. So this is very interesting. The message type here that is not considered important enough by tools like Microsoft Defender for Identity or any other similar tool. So even if you use this against the DC, if you create a silver ticket for a service against the DC, chances of detection are very low. However, there are a couple of tidbits that you should keep in mind when we use silver ticket. Recall that a golden ticket provides access to any machine and any service, but a silver ticket will provide access to only a particular service on a particular machine. Also, most of the interesting services on a machine are run using the machine account. All the services like WinRM, WMI, WSMan, Terminal SRV, CIFS, all of them use machine account as a service account. So your persistence lifetime would be about 30 days. Right? So it is a TGS. You create a TGS and present it to the target service, and it will provide you access. However, persistence period is by default 30 days for computer accounts. So what does the command look like? The module is still Kerberos Golden, user that you would like to impersonate, FQDN of the domain, SID of the domain. These two are new here, the target server's FQDN and the service that you would like to access there. And then RC4 or AES key of the target service or usual ID and groups parameter, the PDT parameter that we discussed, and the timeline parameters that were present in golden ticket as well. So only two new things here, the target server and the service. Once you run this command, this provides you access. So we are running this against the DC. What is this RC4 of? This is the secret of the machine account of DC, DCorp DC dollar. This would provide you access only to the file system. Now, why would you like to, a question is, why would you like to use silver ticket? Because it is much more silent. Tools like, let's say, MDI, Microsoft's Defender for Identity, they protect DCs. They are interested in these message types. This message type is not considered important enough. So chances of detection are really low if you use silver ticket. Silver ticket is not considered important enough or lethal enough, not worthy of detection. So that's why. But it is a very lethal and very useful attack. So this RC4 is of the machine account, which in this case is DCorp DC. So this would be for DCorp DC dollar account. All right. Now, how do you, for example, execute code using silver ticket? By creating multiple tickets. For example, if you want to use WMI, you need to use RPCSS plus host. If you simply create it for host, that allows you to schedule a task. If you create it for HTTP, you can use it for WinRM and so on. So that is what the silver ticket attack is. I've given an example of scheduling a task. However, please treat that as just an example. Scheduling a task on the DC is pretty noisy. A question is, why are we using decode DC dollar machine account hash and not the service? As I said, all the interesting services on a machine, be it CIFS or RPCSS or host or HTTP, all of them use the machine account as the service account. Any service that runs as local system or a local service uses the machine account as the service account. All right. Now, this is for you to practice later on because the commands are pretty similar to what we saw in the golden ticket. Create silver tickets for host service and access the machine using host service, and also for WMI. All right. Now, another persistence mechanism that we can have a look at is skeleton key. So what is skeleton key? The idea is pretty simple. You inject some code in the LSS process on a domain controller so that it allows access as any user with a particular password. That is, you only need to know valid username, and then you can specify the password that you injected. So for example, when you use mimicards, how can you use mimicards to inject a skeleton key? Simply by using this command. Now, when you inject, please note that you need domain admin privileges. We are in the persistence phase right now. When you inject a skeleton key, you can specify a valid username and a password mimicards. So the valid passwords will also work, and your skeleton key will also work in this case. Works perfectly fine against the latest Windows servers. Please keep in mind, however, if you want to use this in a real assessment, at least change the default key. Otherwise, specifically because we are targeting an assumed breach scenario, there could be an adversary already in the network that can make use of this. All right. So that's what skeleton key is. Now, what if a skeleton key is running as a protected process? Then you have to use Mimikatz driver. That is, you have to touch disk on the machine, start a service on the DC that uses the driver, remove the protection, and then use skeleton key or anything else. But this is going to be super noisy. Can we extract RC4 of a machine account using DC sync? Yes. You can. How do you change the skeleton key password? Unfortunately, you have to make changes to the Mimikatz source code and build your own version. There is no argument that accepts that. All right. So I wanted to cover DSRM as well, but we are running out of time actually. So let me skip showing you this one, if that is fine, so that I can discuss DSRM. So we would be pretty caught up with what I planned for today. I mean, I wanted it to go till 12, learning objective 12 actually, but this is fine. We are still on track. So one last persistence mechanism that we can discuss is DSRM. DSRM is Directory Services Restore Mode. So DSRM is something that you need when, let's say, DSRM password is something you need when your ADDS, that is your domain services on the domain controller, refuse to start. All right. So whenever you promote a server to be domain controller, it asks for a safe mode password or a DSRM password. So it is that password that is assigned to a local administrator on the DC, not the default domain administrator, but there is a local administrator on the DC, the DSRM administrator, and this password is assigned to that particular user. Now, it is possible to extract that DSRM password and abuse it. So this is very useful for persistence mechanism. Why? Because the persistence lifetime for this is very long. I've seen organizations who have not even documented their DSRM password, and the person who set the DSRM password has already left the organization years back. And thanks to hot backups of domain controllers, many organizations simply switch to a hot backup if there is a problem with the DC. So no one actually ever uses it. How do you extract the DSRM password? So this is what it looks like when you set up a DC, the DSRM password. So how do you extract the DSRM password? From the SAM Hive. What do you have in the SAM Hive? SAM Hive stores passwords for local accounts. So if you extract, if you of course needs domain admin privileges to do that, we are still in persistence. If you extract credentials from the SAM Hive, you will get password for secrets for an administrator user, and that administrator is not the default domain administrator, that is the DSRM local administrator. Now, once we have the hashes, the NTLM hash of that DSRM administrator, we can use pass the hash, not overpass the hash. We can use pass the hash to abuse it. However, this user is not allowed to log on remotely. So you have to make changes to DSRM admin logon behavior registry key and enable network logon for that user. After doing that, we can use pass the hash. Notice that in the domain parameter, we are passing just the DC name. So use overpass the hash, and then you can access the DC as the DSRM administrator. And that is a very, very useful persistence mechanism. However, it includes a security downgrade. You are downgrading security of the DC. You're introducing a vulnerability there. So if you want to use this in a real assessment, make sure that you get a nod from the stakeholders. Right? So that was our learning objective 11. And that would be all that I'm going to discuss today. So any question on whatever we discussed today? Objective 7B, I believe, guy with the code, that is something that I can discuss in the next session because we are running out of time. Or if it is fine with everyone else, because we have a recording, I can do that one. That would take close to, I believe, 10 minutes. Okay, so I'll go for it. I just needed a couple of nodes. Let me tell you the flag number before I go for that. So up to flag 20. So where's the question where someone asked for the flags? Here it is. Flag 20. So once again, I'm going to go for learning objective 7B. I usually do not extend the lecture time because I want you to attend it live, but because this is recorded, let's take that leverage so that we do not miss it. So let's go for objective 7B, that is escalation to domain admin using derivative local admin. Once again, And I keep repeating that so that it is absolutely clear. This is recorded. That is why we are extending the lecture time. Now, we saw that using both Bloodhound and find PS remoting local admin access, we saw that we have local admin access on dcorp admin SRV as well. So let's try to extract some credentials from that machine and see if we can find some way ahead. Right, I see your question, Rob Pierce, but I'll answer that once this is done. Okay, so let's exit from this. Let me close all the sessions here so that I can start afresh. Let's close this. Now, we found out that we have local admin access to dcorp admin SR as the student X user. So let's access that machine. Or let me do this the other way around. Let's start a PowerShell session using InvisiShell and connect to dcorp admin SR. Now, let's say we would like to run a command here. Let's say run a tool here, invoke mimicards, for example, or anything else. Or when we were using WinRS, let's say we wanted to run our loader.exe. Whenever we try any of those two techniques, we'll get to see something interesting. For example, let's say if I want to bypass MZ here, using our MZ bypass, if I run this, we get a strange error here. Method invocation is supported only on core types in this language mode. Some error about language mode. What's that? Let's check it out. So this is constraint language mode. All right. What's that? It is the CLM that we briefly discussed. Not discussed, we simply touched it. But there is something called CLM. In a normal PowerShell session, you will have a full language mode. But if there is an application allow listing solution like App Locker or Device Guard, that is WDAC, is in use and there is any restriction on executing PowerShell scripts, Windows PowerShell 5.1 gives you constrained language, not a full language mode, regardless of you coming through PowerShell remoting session, or even if you have, let's say, RDP access to dcorp admin SRV, then still you will have a constraint language mode. Now, this is fine. We have a constraint language mode. However, unless you bypass this constraint language mode, none of the tools, PowerShell tools that we have discussed, other than the AD module, will work. So how do we enumerate if WDAC or App Locker is in use? So if we are using PowerShell as we are right now, it is very easy. We can simply run get App Locker policy -effective to get a list of effective App Locker policies. There seems to be a rule collection. This means that at least App Locker is in use here. So there are many rules. For example, it allows some Microsoft signed binaries. The first rule allows Microsoft signed binaries. Second rules allow Microsoft signed binaries or scripts, and there are then a couple of default rules. So this is a pretty poorly created app locker policy, to be honest. Why? There are a couple of default rules. These default rules allows everyone to run scripts that are located in program files or in the Windows directory, C Windows directory. The first two rules allow only Microsoft signed binaries and scripts. Please note that even the couple of first rules are pretty lax, pretty permissive, but these simply kill the use of application allow listing. Now, what is application allow listing, you ask? There are two ways of blocking malware. One is that is used by AVs is you have hashes of known bad code. You have millions of hashes of known bad codes. Whenever new process or DLL or executable runs on a machine, its hash is computed and is matched with the list of known bad code. That's the basis of any AV. The application allow listing is the other way around. So the idea is, at least in the ideal world, the idea is in place of in place of blocking the known bad code, why don't we allow only the known good code to run? That is, let's have a list of known good executables, 100 or 1000 known good executables, and let's only allow that. However, this is only true in an ideal. This line, known good code, that's what the Achilles heel for any allow listing solution. How do you define known good code? A lot of times, people immediately respond with Microsoft signed code is can be assumed as known good code. Is that correct? Does everyone here agree that Microsoft signed code is known good? Okay, I've got no's. I was expecting some yes, so that I can share this then. So look at this URL that I've shared, lolbas. It is also there in the lab manual and the slides later on, living off the land binaries and scripts. So what this project does, it lists Microsoft signed binaries and scripts that can be used to run untrusted code. And as exploiter points out, you can also sign binaries that look like Microsoft signed. So basically, there is no definition of known good. The idea simply is that once again, in the ideal world, you look for in a quarter or a couple of quarters, you look at your machines, keep looking at the logs, run AppLocker in audit mode, and check if there are binaries and scripts that are very frequently used, and then you allow only that. However, I've never seen an organization that is running an allow listing solution in block mode. Absolutely not possible. In fact, this is so true that Microsoft does not, so adaptive application control in Azure, which is AppLocker in the cloud sort of, you cannot run it in block mode. It runs only in audit mode. Sorry. So that's why, I mean, regardless of how stringent or how effective allow listing can be, you will rarely find it in enforcement mode anywhere. And when we compare WDEC, that is device guard, and AppLocker, WDEC is miles ahead of AppLocker, miles ahead literally. Very comprehensive protection. However, we are lucky enough, we only have to deal with AppLocker. So we will, of course, abuse this rule that says that everyone can run any script from the program files directory. I mean, in any case, AppLocker cannot protect from administrators. It is powerless against administrators. But still, let's see if we can still extract credentials from this machine. So let's turn off Windows Defender here using set MP preference. That was actually not required because our invoke mimicards that we are using is not detected even from the disk, but let's use it in any case. Now we have invoke mimicards EX. That is nothing but, if you look at invoke mimicards EX, it is absolutely same as invoke mimicards. The only difference is that we have function call at the very end. That's it. Right? That's the only difference between invoke mimicards and invoke mimicards EX. So let's copy this now on dcorp admin SRV from student VM to dcorp admin SRV program files directory there. And let's interact with the session again. And run invoke mimicards EX. So because the DLL is compressed in this version, it takes some time to extract the credentials. Now, what we will get from here is credentials of a user called SRV admin. So I'll leave this running so that I can come back and show you that. Once we have the credentials of SRV admin, we will use overpass the hash to start a new process as SRV admin. This process runs as SRV admin. And as we have been doing earlier, now we will use find PS remoting local admin access to check if SRV admin user has local admin privileges on any other machine. So first let's run invisishell. Then we will use find PS remoting local admin access to check for local admin privileges on any machine in the network. All right. So SRV admin has local admin privileges on admin SRV and dcorp MGMT. So here our execution is completed. And you will see that we get credentials for a user called app admin, for a user called web SCC, and SRV admin as well. We got credentials for 3 users from here. Now, what do we do from here? Once we know that we have admin access to dcorp MGMT, we can now simply go ahead and use loader.exe to extract the credentials there. So let's interact with dcorp MGMT as SRV admin. We already have loader.exe copied here. Let's make sure that we run the port forwarding. What we are doing, once again, we are forwarding the local port 8080 on dcorp MGMT to port 80 on the student VM to avoid behavior-based detection. And finally, let's run loader.exe to run safety cards in memory. And as we got earlier, we get credentials of SVC admin. And this was our second task of learning objective 7. All right. Our question was, what set MP preference that we used earlier do? It disables Windows Defender temporarily. Works only on server OS as of now, thanks to temper protection, but it still works on server OS. All right. So what we covered today was up to learning objective 11. And the flag number, let me reiterate that. That would be up to flag number 20. This would be flag 20. Right. The question is, this would be by trial and error, like creating OPTH for all users and for the testing. Yes, whenever you compromise a new user, it makes sense to check if that user has local admin access. A question was, if RC4 cipher is disabled on a machine, is this still possible? Or does it matter only on the DC? You have the answer in the question. Yes, it matters only on the DC drop bears. And if RC4 is disabled on the DC, then you have to use AES keys. You can use AES keys even in case of silver ticket. Right? In place of RC4, you can use AES 256 or AES 128. All right, any other question? Okay, so I will not take any more of your time. Thanks a lot. Thanks a lot for allowing me to extend this one by a few minutes. We were able to cover a lot of ground. So with that, let me stop this session. Thanks a lot. Love this session. And see you on Discord and then in the next session. Bye.